Hello all, welcome to the Security Tube Linux Assembly Expert course and certification. Now in this video, we will look at the Execve shellcode creation using the stack method. Now really, when does Execve come in handy? Now it is very useful when you want to execute a new program in your shellcode. Now typically this is bin sh or bin bash so that you can actually get a shell on the box. Now in order to go ahead and do this, we use the execve syscall, which really takes in three arguments. The first is the file name, the second is argv, and the third is envp. Now let me explain what these mean. And just do a quick man execve. And what you would notice is the file name is really the file name of the program which you would like to execute. So let's say we want to spawn bin sh, then file name would have to point to the string /bin/sh. Now argv is really an array of argument strings passed to the program. Now depending on if you have any arguments to pass or not, you could pretty much decide what to put in here. The important thing, of course, is that the first of these strings must contain the file name to be executed, which really means this is going to be file name followed by any arguments. Finally, envp is the array of strings which of the form key equals to value, which are passed as environment. Now in the most simplest invocation, we can use bin sh. argv would basically be pretty much nothing but the address of bin sh followed by a null, and then envp would pretty much be just a null. So let's go back to our PPT. Now from a shell coding perspective, or rather assembly language perspective, if you recall syscall calling, then pretty much, if I would want to map it, then the file name would really need to go ahead and point to bin sh terminated by a null, and this address would be in RDI. argv would really be an address of bin sh in memory followed by a null, and this would be referenced by RSI. And then finally envp, as we've chosen not to pass in any environment variables, would again pretty much be just a null referenced by RDX. So how are we going to go ahead and do this given that there are no nulls allowed in the shellcode? Now this is where we are going to use the stack push technique. Now if I were to visualize the stack from high memory to low memory, which is the direction in which it grows, then pretty much here is how we would do it. First, I'd push in a null on the stack, and then I would push in bin sh on the stack again. Now keep in mind that this null is really just to null terminate bin sh. You could have pushed in a single byte as well. Frankly, you could push in 8 bytes as well. I've chosen to do the 8-byte push. Now this ensures we have a string in memory, bin sh terminated by a null, and we need to have this address referenced by RDI. So let's go ahead and do this. Now to make matters really easy for us, I already have the program written in here. So the very first null push is really this one, and I've simulated this by doing a zor rax and then a push rax, right? This pushes 8 bytes of 0x0 onto the stack. Now next I want to push bin sh, but it's very important to remember that The stack grows from high memory to low memory, hence I need to push in bin sh in reverse order. So how do we do that? Well, this is where Python can again come to our rescue. So I can say shell equals /bin/sh. Now, this really is 1, 2, 3, 4, 5, 6, and 7 bytes. Just so that we can round our push to 8 bytes, I need to add one another byte in here. And this is where a very useful thing about the shell comes in handy. Now really, you can write bin sh, right? Or you could even do a /bin a /sh, and this gives you exactly the same response. In reality, you could have as many of these trailing slashes as you like, and the shell would ensure that it understands what you really mean. So using this trick, I'm just going to go ahead and go back in here and just copying it from the PPT. I'm going to do a /bin//sh. There we go. So this makes it rounded off to 8 bytes. And then I'm going to reverse this string. And then I'm going to encode this in hex. And this value which we get in here is basically what we've put in here. So now I'm going to move this onto RBX and then push RBX on the stack to ensure that bin sh is now on the stack. Now based on the execve syscall, RDI needs to go ahead and point to the bin sh string in memory, and hence the next step would really be moving RSP into RDI so that RDI references bin sh in memory. Fantastic. Now after this, I'm going to push in another null. Now keep in mind that RDX also needs to point to basically a null. So I'm going to push RAX once again, which was already all zeros. And then I'm going to move RSP into RDX to ensure that RDX now goes ahead and points to a null value. Finally, we go ahead and push the address of bin sh in memory, which is referenced by RDI. So just a push RDI would do the magic. And this is really what we've done next. And after that, we are just going to go ahead and reference this with RSI by doing a very simple move RSP into RSI. And there you go. Now, after this, basically, we are simply going to invoke the execve syscall. If you look at the table, as I've shown you before, RAX needs to be set to 59 for execve. And after that, we issue the syscall command. So let's go ahead, use NASM. Let's use LD. Clearly see we have bin sh which has been spawned. And now I can use the previous shortcut to simply go ahead, get the shellcode from in here, copy it out, paste it into our template file, compile it, and there we go. Right, we have our bin sh shellcode. So there are multiple optimizations which may be possible in the given shellcode, which I leave to you as an exercise. I think this probably, in my mind, was the best way to conceptually at least deliver how we can use the stack method for 64-bit shell coding and running Execve. Now, the question you may ask is there a need for exit? Well, keep in mind that if Execve is successful, then there is no need to exit simply because we've spawned an entirely new program which is now handling every single thing. And of course, depending on what the program does, we could make it exit either naturally or it may crash or anything may happen. So really, after Execve runs, pretty much our code gets overlaid by the program we just exec, and hence exit is not required. Hope you enjoyed this video. In the next video, we will analyze the stack technique using GDB to really step through it and see what is happening. Now, if you're enjoying your time here at Pentester Academy, then we would really we'd really appreciate if you could recommend us to your friends and colleagues in the InfoSec community. Thank you and have a great day ahead. Bye-bye.